Okay, so hopefully I can record the in-class sessions as well. They probably won't be as great, as because they won't be quite as focused. But I know especially if people are missing or they're out because of sickness or whatever, this will give them at least an opportunity to see what we've covered. And again, you've got videos for sections 4.1 through 4.3. My plan is to kind of go into the homework and go from there. So I'm going to pull that up already. If I go to My Math Lab online homework, and then I'm going to go to course home. You can go to all assignments if you just want the assignments. There's other stuff in here. Okay, and then I'm going to go to homework, and there we go. Sections 4.1 through 4.3. And this is really, especially going forward into later classes, this is you guys' chance. You tell me the homework, you tell me the problems you want to look at, and we'll do that. I can pick some if nobody picks any, but so I kind of want to give you guys the opportunity. What section, are there any sections or problems that you want to look at? Yes, sir.
I don't like a specific section, but like where, if we like were to tell you before class, like where would I tell you?
You can send me a remind, you can send me an email or text or whatever, so that's fine, or you can just jot it down and I'll pull it up in class too. And so like my first class, I think there was a question on the last section, so we'll do the same. I'll do the same here. I'll pull up this last section that we did and kind of this last question. We'll start there. And then I'll let you guys kind of dictate where we go from there. And we'll spend a few minutes, we'll spend maybe a half hour just reviewing kind of some of these homework questions, and then we'll get into the kind of the meat of the section. But this one's a pretty good question. It says telephone pole shown at the top of the next column is 60 feet tall, and there's a guy wire. I always thought that was guide wire, but apparently it's guy wire. Learned that a while back. Is 83 feet long, and it's attached to the ground from the top of the pole. Find the angle between the wire and the pole to the nearest degree. So you can read the problem. So it's wanting to know this angle here, not the angle with the ground, but the angle between the wire and the pole. So I'm going to come over here to the notes in case anybody wants to look at this at some point later. And also, you get to pick what color. Anybody have a preference? Nobody cares? Good. Blue. All right, I'll go with blue. I was going to go with Big Orange, Tennessee. College football starts tonight. We're all excited. Everybody likes the Big Orange, Ball Nation. So, no, we'll go with blue for now. I may switch later. So we've got a 60-foot pole here, and it's attached to the ground. And I'll just come in here and say, all right, that's 60 feet, and I've got a wire. I've got some angle that I want to know, and the wire I think is 83 feet. So there's a lot of different ways we can do this. Now, one of the things that isn't specified there is that we're assuming this is on level ground. At some point that might not be the case, but for now we're going to assume that's level ground, so that makes that a 90-degree angle. So you've really got a triangle problem is what you've got. So we want to know what theta is. So there's different ways to set this up. My advice would be to use what is given to you and not try to do other things. You could probably determine, what this distance is down here with Pythagorean theorem or something. There's other ways to do it. But I'm going to use this angle, and I'm going to look at the sides, and I'm going to say, well, based on this theta, I have two sides that are given to me. One is the hypotenuse, right? Because it is opposite the 90-degree angle. That is my hypotenuse. The other, on this angle at least, is the adjacent side, right? Because over here would be the opposite side. So I should have a trig function that tells me something between adjacent and hypotenuse. What function is that? It is the cosine function. So for this question at least, the cosine of theta is going to be equal to the adjacent side, which is 60, over the hypotenuse, which is 83. Okay, so the question is, well, what does this give me? Let me write down which question. This is number 16. Okay, so cosine theta equals 60 over 83. And it's going to take me a very long time to get used to that this computer, at least to my knowledge, does not have a calculator on it. If I type in calculator, nothing comes up. It used to, but anyway. So I will go to the Desmos calculator, easy enough. And I've got 60 divided by 83, so, and I get this number for 60 divided by 83. But I want to take the inverse cosine. I'm not sure how that is on here. This calculator. And it's probably going to be in radians, so let's do, I really don't like using this calculator apparently. Well, on this calculator at least, I'm getting a value of 0.7628. Now that's in radians. I'm going to convert this to degrees because I want to, because I'm used to using degrees here, so I'm going to say this value, if I multiply that times, if it's in radians, I want to multiply by 180 divided by pi. So I get 43.71 degrees or so. So what I'm really doing is taking the inverse cosine of both sides. And I keep hitting the button there. Meaning that that's just going to be theta equals, and then the inverse cosine of that, which I got is 43.71 degrees. So let's kind of look back at the problem. It says to the nearest degree. So to the nearest degree, that would be 44 degrees, if I've done that correctly using this calculator. Okay? Does that make sense? Any questions on that? Now, most of your calculators may be in degree mode by default. So that's another reason I use degrees a lot for some of this. Word problems in particular. Okay, so any question on that one? Okay, I think the one before it's pretty similar. You're setting it up, you've got a triangle. We'll take a quick peek at this one. This was number 15. So this one's set up very similarly. I have a 7-degree angle. I'll scale it down a little bit here. And that's a right angle, believe it or not. And 450 feet, and I want to know C. Okay, so in this case, I'm looking to figure out what C is, and now here's my angle. And I've got two sides again. One is my opposite side. The other, opposite this 90-degree angle, this is my hypotenuse. So I'm going to come in again. I'm going to say, well, which one has opposite and hypotenuse? Well, that would be your sine function, right? Sine, opposite over hypotenuse. So I would come in and say, well, the sine of 7 degrees then has to equal 450 over C. And you could go through the process of solving this out for C. If I multiply both sides by C, I guess C times the sine of 7 degrees equals 450. And then you divide both sides by the sine of 7 degrees. So you really get C equals 450 divided by the sine of 7 degrees. And let's calculate that. So I'm going to say 450 divided by sine. And I really wish I could switch to degrees somehow, but I can't. So 7 degrees, so in this calculator at least I have to say 7 times pi divided by 180. That puts me in radians correctly for this calculator.
Can you be in that little settings button?
You know, let's try it.
Or to the right? Yeah.
I think that's more for graph
Oh.
settings. You know what's interesting, and I haven't used much. Let me just check something real quick. Instead of graphing calculator, I thought they had just a calculator, scientific calculator. So now, yeah, okay, so we'll try that. So I got 450 divided by the sine of 7, so I'll just say and I get the same answer that I had before, 3,692 point. And I like to keep decimal places till I don't need them, so I'll say 3692.48. Now I have to go into my problem and see kind of what the units are and all that. So 7 degrees, 450 feet. So I'm looking for the distance to the nearest foot. So in this case it would be 3,692 feet. Hopefully. Okay. So there are 16 questions on this section. Is there any one in particular you want to look at, or do you want to look at a different section? What do you guys want to look at? Or you pick a number.
We do one on section 2.
Section 2? We can do that. Maybe.
I wish I was farther along than I am. I haven't had time to go up and work.
Oh, that's fine. So let's look at section. Actually, I had a question. I think it was from 4 point. Well, it might have been 4.2. It might have been 4.1 actually that I need to go over. This one's interesting. I get questions on this one a lot, so let's do this one real quick. And this is number 22. Okay, so it says sine of t is A, cosine of t is B, tangent of t is C. Write the expression in terms of A, B, and C. So this is really using the properties of sine and cosine and tangent and even, odd, some of that kind of stuff to really make a simpler problem. So if I have negative sine of negative t, let me write this. Well, you know what? I probably can't. Wish I could just copy that. Maybe I can. Close. Let's see. I didn't mean to do that. Oh well, that's close enough. So I have negative sine of negative t minus 8 pi. So I can rewrite that a little bit though, right? Because if you remember sine and cosine, they have a period of 2 pi, right? That complete rotation. So I can always add or subtract 2 pi from a sine or cosine. I'm going to get the exact same answer because all I've done is gone right back to the exact same spot on the unit circle or the exact same angle representation. So really this is the same as negative sine of negative t, and I'll just say minus, really that's 4 times 2 pi. So that's not changing my angle at all. I'm just subtracting 2 pi 4 times. And you don't have to go to that level of detail, but that's all you're doing is subtracting pi that number of times. So that's really the same as the negative sine of negative t as is. Is everybody okay with that? Because all I've done really is just gone around that circle 4 times. So I'm at the same point. Those are the same values. Cosine, this part's really kind of the same. I've got plus cosine of negative t, and it's got minus 6 pi. Well, that's really the same as minus, I guess, 3 times 2 pi. Meaning I've just gone around that circle 3 times. But I'm at the exact same point. So that's really the same as plus the cosine of negative t. And then finally I've got plus tangent. And this one's a little even more simple in some ways because the period of tangent and cotangent is pi. Meaning I'm going to be at the exact same ratio on either side if I just go a 180 or go pi distance away. So that negative t minus 5 pi means I'm still at the same place because I've gone some number of pi some number of times, in this case 5. So it's really the same as plus tangent of negative t. Is there any question on that? Does everybody kind of see that? Okay. So any even part of pi that I've added or subtracted the cosine, you can just get rid of. And any ratio of pi that I've gone as far as tangent whole number wise is going to get rid of it. So the next part of this is really, well, what do I do with that negative t that's in sine, cosine, tangent? And if you go back, and it's kind of really from that first section, we talked a little bit about this. If I have some angle, say t, now I'm at some point, right? If I go the exact negative t, then what am I at? Well, the x-coordinate has not changed on my unit circle, right? So the cosine is exactly the same as it was. So cosine of negative t is actually the same as the cosine of positive t. The y-coordinate has changed. It's exact same distance from the x-axis, but it's now negative instead of positive. So meaning if I had negative sine of negative t before, if I change that to sine of just positive t, that changes the sign out front and makes that just positive sine of t. In the same way with tangent. So that's going to become minus tangent of t. Okay, so that ratio of x to y down here is negative what it was up here. Does that make sense? Sort of? In 4.2, those are a couple of the functions as you go back in. I'll take a peek at that real quick. If you go into 4.2, those were a couple of the things. So here's kind of that discussion about even and odd and all that kind of stuff. So sine of negative pi over 4 should be the same as negative sine of pi over 4. Secant of negative pi over 4 is the same as secant of pi over 4. It doesn't change its sign because it's, along with cosine, is considered an even function. Okay. Okay. So given all that, now I can go back in and say, all right, what was I trying to find here? A, B, and C. So sine of t is A. Okay, A. Cosine of t is B, so plus B. And then minus the tangent of t, which we're saying is C, so minus C. So A plus B minus C, I think, is hopefully correct. Okay? Okay, so this one's really very similar, right? Cosine of t plus 2400 pi is exactly the same as the cosine of t. Okay? All I've done with 2400 pi is just added 2 pi, I guess, 1200 times here. So it's not changing the value. Same for the tangent of 177 pi, same for this one, right? It just becomes sine of t. This will become tangent of t. Okay? So, which one you want to look at? You guys pick. I don't know how many questions there are. Used to, there was a little button up here I could look at all the different questions, but there's at least 23. So there's 23 questions. We've done one, sort of 2 of them. Is there another one you want to look at? Or pick a number. This is 4.2. So how far did you get in 4.2? Halfway? More than halfway? Haven't started 4.2. Well,
You could do any one in the section if you like.
all right. And we'll pick a number. We'll do it. 15. All right, let's go to 15. Okay? Find the exact value of the given trigonometric function. So it's going to have something to do with pi over 4. Those are what we know given this section. It says do not use a calculator. Oh, that's handy. So sine of negative pi over 4 minus 5400. So again, that negative 5400 pi means nothing in this case. That just means we have gone around a circle 2,700 times, but we're at the exact same point on it as far as an angle goes. We're at the exact same angle. So that's really the same as let me just write it in here. Negative pi over 4 minus 5,400 pi. It's going to be equal to the sine of negative pi over 4. Okay. So we can keep going with that. This is in one of those odd functions, right, sine y-coordinate changes. So this is odd, so that makes this, if I'm taking sine of negative pi over 4, that's the same as negative the sine of pi over 4. Okay, now there's different ways to calculate that. You can use your circles, you can use triangles. If I use triangles, and we'll discuss this more today with unit circle and stuff like that, if I remember those ratios of 1, 1 square root of 2, and that being my angle, then that opposite over hypotenuse is going to be, so I'm going to have negative, and then we'll have 1 over square root of 2. Well, if I multiply the top and bottom by square root of 2, to rationalize my denominator, I get negative square root of 2 over 2. Now that's also from unit circle. If you go back to that first section, we kind of derived that using that unit circle definition as well. But the sine and cosine of a pi over 4 angle is square root of 2 over 2. So in this case, we had negative sine of pi over 4, so it's negative square root of 2 divided by 2. Good question. Others? Okay, the last one I'll pick out then, because this was one that I was asked before class, tried to go over, but just in case. Oh, let's. Oh, we do have orange. Okay. And I don't remember which problem it was, but it was something like this. Let's say I have negative 23 pi over 5. And I am looking for coterminal angle, positive, that is less than 2 pi. So somewhere on that 0 to 2 pi circle, I want to find that same angle, but I want it to be coterminal with that. So the way you're going to do that, the way you would approach that, is I can do just kind of what I've been talking about. I can say, well, I can add 2 pi to that. That's not a problem, right? I'm at the exact same point if I add a complete circle, and I'm right back where I started. So if I take negative 23 pi over 5, and I say, well, I can add 2 pi to that. That's okay. Nothing wrong with that. But first thing you might notice is, well, I can't do it directly. I need a common denominator. So to find a common denominator, I'm going to take that 2 pi and I'm going to multiply it by 5 over 5, because that gives me a 5 in the denominator, and I get whatever in the numerator, but I'm just multiplying by 1 effectively. So that's really the same as negative 23 pi over 5 plus 10 pi over 5. Now that's helpful. I can do that one time, but I'm still going to have a negative number, right? So I want to keep going. I don't want to just do it once. I probably want to do it twice. I may want to do it 3 times. So you can figure that out and go down that road, or you can just continually just add it. So in this case, I would get negative 13 pi over 5. So I'm just going to repeat that, right? I'm going to add 10 pi over 5 again. So that's going to give me negative 3 pi over 5. Well, that's still negative, still not positive, so I got to redo it again. So I'd say, well, plus 10 pi over 5. And that gets me to 7 pi over 5. And so that one's good. Now I'm positive, so at least I've got that part taken care of. Just make sure that you're still less than 2 pi. Well, we said 2 pi was 10 pi over 5, right? So we are between 0 and 2 pi at this point. So this would be the answer in this case, 7 pi over 5. So that was a good question. Does that make sense? Yes, sir.
So like, what if you didn't end up being below 2 pi, or like in between 0 and 2 pi? Like obviously it didn't happen here, but like then what do you do after that?
Then you've probably made a mistake somewhere.
So
because
it doesn't happen, right?
I'm sorry?
Like it won't happen if you get it right.
Correct. No, you will not get outside of that, because every angle has a representation. If you're just adding 2 pi, eventually you're going to get somewhere between 2 pi and 0. Now, if it's in degrees, remember, you're not doing 2 pi anymore, you're doing 360. So you might add 360 twice, you might add 360, more than twice. Maybe subtracting 360. So that would be the other case, right? So if I had something, let's say I had an angle, 850, right? I would subtract 360. That would give me whatever. And now I would subtract 360 again, and it would give me an angle that is less than 360 at that point and bigger than 0. So you're either going to add or subtract 2 pi or 360 some number of times. Okay. Other questions, comments, inputs? All right. So I'm going to move on. I'm going to start into section 4.4, and we'll go from there. 4.4 is really kind of combining everything from 4.1 through 4.3 and just say, all right, I want to find trig functions, not just of, these 2 or 3 special angles we've talked about and these given quadrants. Even though there's ways of doing that, this allows me to really find trig functions of pretty much these angles in any quadrant. So last section we really looked at acute angles in that first quadrant. We formed right triangles, and probably the way, if you went through that, was we said, hey, we're going to drop this line from the end of our angle down to the x-axis. So you can kind of see here this line here, and we did triangles. And that's what 4.3 was kind of about, which is my technique usually for solving these trig functions. You can also use the unit circle kind of definitions that we've done as well, right? So, but for example, let P being 1, -3 be a point on the terminal side of your angle. Now, that's not on the unit circle, so I can't just use those point coordinates as is. It says find each of the 6 trig functions of theta. Okay, so when I do that, I can come in here and kind of sketch it out. 1, -3 means, I don't know, I've come over here 1 and -3, so that's going to be down here somewhere. I'll just sketch it out. So this is a point on the terminal side of my angle. So based on my kind of right triangle way of solving these, I can kind of come in here and say, well, that's my angle. I can draw this perpendicular thing here to my x-axis. And I know some stuff, right? I know that this length of this side is 1. The length of this side is 3, but I'm going to say -3 because it is, at least in coordinate-wise, that's where we're at. And then I've got this other side, and that's my hypotenuse. So I'm going to call that C. So if I do that, I can figure out what C is, correct? Okay. How would I do that? Yeah, it's Pythagorean theorem. I have a right triangle at this point, and I have this side squared plus this side squared length would have to equal my hypotenuse squared. So I'm going to have C squared equals, in this case, 1 squared plus -3 squared. Just Pythagorean theorem on right triangles. So that gives me C squared equals 1 plus 9. So I get C squared equals 10. Now again, for hypotenuse lengths, that's kind of a radius for a circle, right? I'm always going to let that be positive. So I'm going to say, well, then C would be the square root of 10. If I take the square root of both sides, I have a value for that. So now I have some angle here, and I have the length of all 3 sides of that angle. So I'm going to use SOHCAHTOA now, basically, to tell me what sine, cosine, etc. are. So in this case, I'm going to come in here and say sine of theta. And just to review, that is your opposite over hypotenuse. So in this case, the opposite side on this angle here is -3. And my hypotenuse is square root of 10. Okay? Does that make sense? Is everybody kind of okay with that?
How did you determine -3 was the opposite side?
Because that was the y coordinate, so that's the distance, right, of this from the x-axis to here is -3, or 3, but -3, right? if you think of it as pure distance, you just have to remember what quadrant it is in. So the y coordinate there is going to be negative. So I'm still not done with that because I need to simplify that denominator. I can't leave that as is. I need to rationalize that. So I'm going to multiply the top and bottom by the square root of 10 to do that. So that gives me negative 3 times the square root of 10 divided by 10. Is everybody okay with that? Okay, cosine, very similar. But it is the adjacent side of your triangle over the hypotenuse. So in this case, adjacent to this angle is this 1 here, not the negative 3. So it would be 1 over square root of 10. And if we simplify that down, I'm not going to go through that again, multiply top and bottom by square root of 10, we get square root of 10 over 10. Okay, so that's sine and cosine. What about tangent? Well, there's different ways we can do tangent because we've done sine over cosine, but we can also do opposite over adjacent. So we'll say opposite side over adjacent. So the opposite side we've already determined is negative 3. The adjacent side is 1. So we get negative 3 for the tangent. Okay? Questions on that? Comments? Okay, I'll slow down for just a second. Let's catch up. Okay. So we're going to keep rolling with this. I'm going to come in here and say, all right, cosecant of theta. And remember, that's sine flipped. Well, I don't want to flip this because then I have to simplify again. If I take this original form and flip it, though, I get negative square root of 10 over 3. And you should get that same answer if you take negative 3 times square root of 10 over 10 and flip that and simplify the denominator. Things will cancel. You should get back to the same thing. Secant of theta, I'm going to flip cosine. So I'm going to flip that as square root of 10 over 1. Okay? And for cotangent, I'm going to flip my tangent, which we said was negative 3 over 1, so it's going to be negative 1 over 3. Okay? Does that make sense? Any questions on that? Okay, so the next one's really just kind of a review. Now, here's the way I kind of look at these. There's you got your unit circle, you got your triangles, all that kind of stuff. When it comes to these 4 angles, or their coterminal angles, that fall on the axis, I usually think purely of a unit circle. All right. So a unit circle, and my drawing's not great, I apologize, but means that I've got these, at these angles at least, I am on that unit circle, and we should know the coordinates, right? If this is a unit circle, that's going to be the point 1, 0. This is going to be the point 0, 1. This is going to be the point negative 1, 0. And this is going to be the point 0, negative 1. Okay? So if I come in and say, well, what's the sine, cosine, tangent of a 0 degree angle? Well, the sine, again, is the y coordinate. So that's just 0. The tangent, I'm sorry, the cosine is the x-coordinate, or 1. So the tangent of theta is sine over cosine, so 0 over 1, which is 0. Does that make sense? Okay, so this really goes back to, I guess, the second section where we were doing that unit circle. Okay, so the next one says, all right, theta is 90 degrees, so that's this angle up here. It's really the same deal, though. I'm going to say, well, the sine is the y-coordinate on the unit circle. So that's going to be 1. The cosine of theta is going to be 0. So what's the tangent of 90 degrees then? Anybody? plug it in if you're not sure. What is the tangent of 90 degrees? Anybody get anything? Should be undefined, right? Because you have 1 over 0. You can't divide by 0. So it's NA, or does not exist. Okay. So you could keep going down there. Obviously 180, the sign is the y coordinate. So it's 0. Keep hitting that button. It messes up. So 0. Cosine of 180 is equal to the x coordinate, which is -1, and the tangent of 180 is 0 over -1, or 0. 270, you keep going, sine of that is the y coordinate here, so -1. Cosine of theta is 0, x coordinate, and the tangent of 270, or 3 pi over 2, is -1 over 0, so it does not exist again. Okay. So you've got your 4 corners that we've kind of determined. In the other sections, if you go in, you'll notice we've kind of got this 60, 30, and we've got this 45 degree angle. So we should be able to figure out the sine, cosine, and tangent of 30 degree, 60 degree, 90 degree, 45 degree, 0, 90, 180, 270, etc. Or their radian equivalents. Now the other thing you can kind of look at is I can say, well, I can come into my quadrants and I can kind of determine what the sine of all my trig functions are going to be. So again, I kind of look at unit circle on here and I say, well, in quadrant 1, my x is positive, my y coordinate is positive, so all my trig functions are going to be positive there, right? Because tangent's positive over positive, etc., etc. In quadrant 2, it says sine and cosecant are positive, so that kind of makes sense. Unit circle, I got a point up here. That x coordinate is negative, right? The y coordinate is positive. So sine is positive, cosecant is positive. Cosine is negative. Secant would be negative then. So tangent is sine over cosine, so it would be a positive over a negative, so it's also going to be negative. And you could keep going with that, right? So in this quadrant, your point, wherever it's at, would be a negative and a negative. All right? Kind of makes sense. Sine's going to be negative. Cosine's going to be negative. Tangent, negative over negative. So it is positive again. Okay? It's kind of that whole 180 or pi period of tangent works out there. And then finally, in this 4th quadrant, you got a point out here, and those coordinates are going to be positive and negative. So cosine's going to be positive, sine's going to be negative. Tangent then would be negative. Really, the way this is usually remembered is you'll see a little thing that looks like this, and you're going to see A for all functions, S for sine / cosecant, T for tangent, cotangent, and C, Aztec, ASTC. That way you can remember quadrant 1, 2, 3, 4, which functions are going to be positive and which ones are going to be negative in which quadrant. And we're going to use that at some point. We're getting it. Okay, sketch a random angle in quadrant 2 on the board to determine the sines of the trig function. Well, we've kind of done that, so I'm going to skip past that. So the next one says, if sine is negative and cosine is negative, name the quadrant where the angle lies. So which quadrant, 1, 2, 3, 4, would be where theta is? That is correct. That's all it's in. Sine. 3. Right, that's going to be in quadrant 3, right? Tangent and cotangent are positive here, but sine and cosine then are negative. Yeah. Okay. The next one says, given that tangent is -1/3 and cosine of theta is less than 0, find sine and secant. Well, the first thing we might want to determine is what quadrant is this going to lie in. And it is probably going to be the second, right? So tangent's negative, cosine is negative. So for them both to be negative, that means sine's going to be positive, which is in this quadrant. See, if this one tangent would be positive, this one cosine would be positive, this one all would be positive. So it has to be in quadrant 2. So we know that. So I'm going to come in, I'm going to kind of sketch this out. I am in quadrant 2, I've got an angle. It's kind of similar to what we just looked at, right? My tangent at least has a ratio of -1/3. And tangent, again, if you remember correctly, is opposite over adjacent. So that means my opposite side is going to have a length of about 1, right? My adjacent side is going to have a length of 3. Now, I like to go ahead and put the correct sign on the x and y coordinates based on which quadrant I'm in. That might help me. But the thing I don't know is I still don't really know what that is, right? I still don't know the length of that side, which I will need. That is my hypotenuse. So to do that, it's kind of like that first one. I'm going to go in and I'm going to say, well, by the Pythagorean theorem, 1 squared plus -3 squared has to be equal to c squared. So I'm going to have 1 plus 9 equals c squared. So I get 10 equals c squared. Same deal, square root of 10 is equal to c. So given that, not even knowing what my angle is, I should be able to figure out what the sine of theta is. Sine of theta is going to be the opposite side, which is 1, divided by my hypotenuse, which I just said was square root of 10. So if you simplify that out again, just multiply top and bottom by square root of 10, you get square root of 10 over 10, and sine is positive as we expected, right, in that quadrant. Secant of theta, well, we got to think about that one a little bit. I usually do this a little bit differently. Anytime I see secant, I come in and say, well, what's cosine? Because that is the reciprocal function. So the cosine is the adjacent side, or -3, over square root of 10, the hypotenuse. Meaning that the secant is that flipped. So the secant of theta would be equal to, and I'll keep the negative sign, and I'll just make that square root of 10 over 3. Okay? And you could find the other functions if you wanted to as well. Is there any question on that? Or anybody not seeing how we're getting there? All right. So let's keep going then. Now, we can do that again. The way I do these is I typically find my angle, figure out which quadrant it's in, and I draw my triangle in that given quadrant and put in the correct coordinates, and that's how I remember the trig functions for all these different angles. There are other ways of doing this. The book is going to do it a little bit differently. But the key is you need to be able to determine, though, either way, what the reference angle is. Now, the reference angle is a little bit different than the coterminal angle, right? Coterminal, I'm at the exact same terminal side. I've just gone around the circle how many other times? For a reference angle, it is really that acute angle, so it's going to be between 0 and 90 degrees, that is formed once I drop that perpendicular to the x-axis. So that's different for different quadrants. So the way I look at this is I try to come in here and say, all right, I have angles in different quadrants. In quadrant 1, my theta prime, or my reference angle, is just going to equal, right, whatever my original angle theta is. So if I give you a 40-degree angle, the reference angle is 40 degrees. If I give you a pi over 5 angle, the reference degree angle is pi over 5, right? Between 0 and 90, or 0 and pi over 2. Now that's a little bit different if you think about this second quadrant, though, right? Here, theta prime isn't just equal to theta, so let's sketch it out a little bit. I've got some angle over here, and here's kind of my angle. There's my angle. That's not the angle I want to know. That is my theta. But I want to know, really, is this angle. What's the measure of that angle? Okay. So if you go all the way around, and I want to know just this part, if I went all the way around, I would be on this line, right, the 180 or pi line. If I subtract out my theta, which is just this part, right, then I'm left with this measure. So in quadrant 2, theta prime is the same as 180 minus whatever the given angle is in that standard position. Or, another way of thinking of it is pi minus theta, depending on whether it's radians or degrees. So I can find my reference angle in there by just taking 180 and subtracting out the given angle, or pi and subtracting out the given angle. Okay? So if I come down here to this quadrant, it's going to be kind of similar. Theta prime is equal to, now in this one I want to know only this part. I am given, though, right, all of that. So this is very similar, but instead of subtracting out the angle, I want to subtract out this part here, this 180 part. And that leaves me with what my angle is. So I would say that's going to equal theta minus 180, or theta minus pi. And you'll get more comfortable with this as you kind of go along. And then finally, the last one we'll discuss is I've got some angle down here, quadrant 4, and I want to know this angle. Okay. In this case, I want to know, and now again, I'm given something a little bit different, right? And this gets messy, so I'm sorry. But what I am given, I don't know if this will show up good or not, but I'm given that part. And that didn't show up great, but I want to know what's left there. So this is kind of like that 180 case. If I come all the way around to 360 and I subtract out all this stuff that I'm given, then I'm left with only that part. So in this case, theta prime is equal to 360 minus theta, or 2 pi minus theta. So given a coterminal angle, I should be able to determine that reference angle in all 4 quadrants. Okay, so let's do that a couple times here. So I have a theta equals 210 degrees. So what do you think the reference angle? First question might be, which quadrant is that in? It is in the 3rd quadrant, right? So that is in quadrant 3, and you can kind of sketch that out, right? So that's 180, 210 somewhere down here. So it's in quadrant 3. Based on that, I'm going to take this kind of knowledge up here and say, well, that's going to be 210 then minus 180. So it gives me a theta prime of 30 degrees. That would be my reference angle. Okay. Does that make sense? So that's the angle between my terminal side and the x-axis. Okay, what about 7 pi over 4? What quadrant is that in? That's a little harder. Thinking back in radians now. No, actually. It'd be in the 4th quadrant, right? Because if you go all the way around, I'm at 8 pi over 4, right? So if I go just another 45 degrees backwards, I'm actually going to be in quadrant 4. Okay. So again, if we think about that, if I go all the way around, this would be 8 pi over 4. So if I go back 1, that would be 7 pi over 4. And if you go back further, right, that's 6 pi over 4, 3 pi over 2, etc. So I'm in quadrant 4, so what do I do?
360 minus...
Yes-ish. Not 360 though. 2 pi, because I'm in radians. So I'm going to say 2 pi minus 7 pi over 4. So I need a common denominator. And again, 2 pi, that's the same as 8 pi over 4 minus 7 pi over 4. Okay? So I'm going to get pi over 4. That's your theta prime. That's your reference angle. Okay? Okay. So the next one says negative 240 degrees. So the first thing you probably want to do is get in that between 0 and 360 or 0 and 2 pi. That's where we're going to look to get that coterminal angle first, and then worry about where your reference angle is. So first thing I would do is add 360 to this, and that gives me a theta, not a theta prime, but a theta coterminal angle of 120 degrees. Okay, so that's your coterminal angle in that first unit circle kind of sense. The next thing is, all right, which quadrant does 120 degrees lie in? It is in 2, right? It's between 90 and 180, so that's in quadrant 2. So that means, what do I do? Well, you go up here, you say, well, that's going to be 180 minus 120, okay? So theta prime in that case would be 60 degrees, okay? Any questions on that? Okay, and we could keep going with that. This next one is theta equals 3.6. So you kind of got to determine first first thing you'll notice is it's not degrees. Right? I am in radians, there's no degree symbol. So the first thing you might need to do is say, well, where's it at? So let's come in here and say, all right, if I still have that pulled up somewhere, maybe. Yeah. So I have 3.6 radians. So I know pi is 3.14. What about 3 pi over 2? So if I'm between pi and 3 pi over 2, that puts me in the third quadrant. So let's see what that is. 3 times, let's see, pi, yep, divided by 2, that's fine, is 4.71. So it is in that third quadrant. So it would be quadrant 3. So that means I'm going to come in here, I'm going to take theta minus pi. So I'm going to take that 3.6 minus pi. So I'll come in here and say 3.6 minus 3, actually pi. And I get 0.458. Okay, so that one's a little bit different. I don't typically give you ones like that where it's kind of a weird angle in radians, but it's possible. You can still go through the same process. Okay, so the next part is really the same as the others. It's just, again, try to get to that coterminal angle first. So I could come in here and say, well, minus 360 gives me a theta. Let's see, 5, 6 minus 6 is 0, so 305. That's in the fourth quadrant, right? So theta prime would be 360 minus 305, so it would be 55 degrees, okay? Okay, so that's kind of the same process here. The next one you would do kind of the same thing. I would say, well, I want to subtract 2 pi, which is 8 pi over 4 from that. And that gets me to 7 pi over 4. Now I'm between 0 and 2 pi. And we've already done 7 pi over 4. We've already determined up above that it is at a pi over 4 reference angle. Okay. Same thing with this one. I could say, well, let's add 6 pi over 3 twice. So I could say, well, plus 12 pi over 3. And I get, hey, pi over 3. So that's in quadrant 1. So that means my reference angle, theta prime, is that exact same thing, pi over 3. Okay, now I went through those kind of quickly because I wanted to kind of, those are kind of similar. Okay. So, I want to take attendance before I forget, because somebody's already left and I didn't catch who it was. So, oh, I haven't even set it up in here. Give me just a second. That's fine. Well, that's true. I did take it on my other sheet last time, so there was one other thing I wanted to set up on here, I think. Yeah, I do want to. I'll send. It'll send an email if you're absent, basically. And plus, this helps me kind of learn names. So, is Cody here? Okie doke. Tawo. Oh. Leah. Oh, everybody gone today. Peter Bray. All right. Kevin Brown. Thank you. Tyler Clark. Thank you. Leslie, she's out. Brandon, okay. Amos, nope. Andrew, thank you. Jerry Mason, Lane Mason, maybe. Hannah Miller, thank you. Jacob is here. Colton, all right. Michael, all right. Sarah Schwab. That might have been who left. I don't know. I'll put other right now. Tim is here. Robert. Zach. Thank you. All right. I think Sarah is who left. I'm not sure. I don't think it was Leah, but I don't know for sure. So I better just, she can tell me if she was here. There we go. And really, this again, I don't have a strict attendance thing. It's really more for bonus purposes, right? If you miss 0 times, you get plus 5 points. And that's classes that actually meet in person. Okay. So attendance, I do want to get back. So this is really the meat of the section is this next few questions here. Final. So there are different ways to do this. The book is going to go through a process in which they say, all right, determine the reference angle, determine what sign your function is going to have based on that reference angle, and then plug in the value that you know between 0 and 90, basically. I use triangles. Some people, most people, I would say even, use what is considered a good filled out unit circle. I do not give this on test, although if your test or take home, I guess you have access to it. But it basically is a drawing of the unit circle. So we know these points, right? For a 30-degree angle, if you go back to sections 2 and 3, especially 3, we sketched out and said, all right, we have a 60, 60, 60, equilateral triangle. If we cut it in half, we have a 30, 60, 90. And we said if each of those sides was 2, we split that one, it's in 1. So we're able to sketch out kind of that triangle, and we were to derive, sine and cosine. So for a 30-degree angle, or a pi over 6 radian angle, the sine, we said, was 1/2. The cosine was square root of 3 over 2. So in each of these... each of these cases, these coordinates are really giving us the cosine of theta, comma, the sine of theta. They're drawn on a unit circle, so that's that x and y coordinate. So for a 45-degree angle, or pi over 4, we said the sine was pi over 4, cosine was pi over 4. For a 60-degree angle, right, these are essentially flipped, right? So we have the sine being square root of 3 over 2, the cosine being 1/2. Okay, now we can translate that to other reference angles, right, in throughout this unit circle. So just like for this one, right, 11 pi over 6, this 330-degree angle, my x-coordinate is exactly the same, right? I'm the exact same x distance away. It's just that y is now negative. So you can derive, if you know the coordinates for these points in this first quadrant, you should be able to flip it around to get to the coordinates of the points on the other quadrants. So when I come in here, and usually what I say, sine of 300 degrees, well, that's easy enough. I go to 300 degrees, and I go to the y coordinate, and it is negative square root of 3 over 2. If you've got that whole unit circle, that's easy enough to do. The way the book kind of goes through here, they say, well, let's figure out, first off, we're in quadrant 4. So that means my theta prime, in a degree sense, is going to be 360 minus 300. So we get a theta prime is equal to 60 degrees. We're in quadrant 4, so ASTC, sine is going to be negative. So all I really need to do is say, well, I'm going to have negative, whatever the sine of that 60-degree reference angle is going to be my value. If you remember that sine of 60 degrees is square root of 3 over 2, then you're going to have negative square root of 3 over 2. Okay, so either way, you're going to get the same answer. Now, finally, I'm going to show you the way I do it, because this is the way I learned it, and most people don't do it this way anymore, I've learned. I see 300 degrees, and I kind of do the same thing kind of in my head. I say, well, that's a 60-degree reference angle, but I'm in quadrant 4, so I'm going to kind of have this situation. 60, 30, 90. My long side is always 2. My short side is always 1. So that makes this my square root of 3 side. So I've just kind of memorized those 3 distances for a 30, 60, 90 triangle. And so I come in here and say, well, since I am in quadrant 4, my x-coordinate is positive, my y-coordinate is negative. So now I've got this triangle, and I can figure out, well, the sine of that is the opposite, negative square root of 3 over 2. So negative square root of 3 over 2. So I am open to using other methods, but that's probably what I'm going to do. So if you see me doing these in class, I'm probably going to be sketching out my triangles and doing them that way. If you use unit circle or you use this sketch, that's fine too. If I give you a circle on a test, it's going to be blank. I will expect you to be able to fill that in. And there are tricks for that. I'll walk through that real quick. 30. Oops. 45, 60, pi over 6, pi over 4, and pi over 3. Those are kind of your 3 special kind of angles, not 0, 90, all those. And I may struggle with this, so bear with me. 3, 2, 1, 1, 2, 3. Okay. Anywhere where I have a 2 now, I'm going to put a square root symbol over it. And then I'm going to put everything over 2. Oh, square root of 3 too. I'm sorry. Those are square roots. So that's another way you can remember those coordinates, at least for those 3, and then you can translate those to other points. So, practice. The more you do these, the more you're going to get kind of familiar. You're going to kind of see it. So tangent, when I see tangent of 5 pi over 4, I say, well, that's 4 pi over 4 plus another pi over 4. So I've got this reference angle down here, and it is a 45-degree angle. In that case, my short side's always 1, and then this long side is my square root of 2. It's negative and negative, based on the coordinates. And so I come in here and I say, well, that's opposite over adjacent, so it's negative 1 over negative 1, or 1. Okay. If I come in here, tangent 5 pi over 4, it's y over x, so it's negative square root of 2 over 2 divided by negative square root of 2 over 2, which is 1. Secant of negative pi over 6, this is a good one. First off, negative pi over 6 is the same as negative 30 degrees or whatever. But I want to get a coterminal angle, so I'm going to add 12 pi over 6 to get a coterminal angle. So that's the same as the secant of 11 pi over 6. 11 pi over 6, well, I know that that is in the 4th quadrant, and it has, obviously, a pi over 6 reference angle. So that's going to be my 1, 2, square root of 3 triangle. That's, oh no, that's positive. That's negative. So my secant is going to be the opposite of the cosine. Well, cosine of 11 pi over 6 is square root of 3 over 2, right? Adjacent over hypotenuse. So the secant of 11 pi over 6 is that flipped. So I get 2 over the square root of 3, and I need to rationalize that denominator. So I multiply top and bottom by square root of 3. So I get 2 times the square root of 3 over 3. Okay, so I realize I'm going through that kind of fast, but I just want to point out, these aren't as bad as they may seem. And you've got your unit circle. So we're a couple minutes from class being over, so I'm going to probably go ahead and call it. On Tuesday, we're going to finish up. We'll go into homework, make sure we're on the same page for all of this section. There's a couple in there. My son actually asked me one the other day, something like, find the tangent of negative 17 pi over 4 or something like that. So it's kind of this same process. Get that coterminal angle, figure out your reference angle, and then you've got your tangent. Don't forget on Tuesday that your quiz 1 is due. You've got a paper copy now. Just make sure that gets turned in. And I think that's all I got. If you have questions or need anything, let me know. The videos from the past sections are online. And other than that, have a good weekend. All right, you too.
I want to ask how you originally got the square root of 3. I'm sorry, I didn't mean to-
No, you're fine.
Above the triangle there?
Yes. So in that section, I believe it's in 4.2 or 3. So in the first section, we had unit circle, and we kind of set up pi over 4 kind of 45-degree angles. In the second section, we did that again, and then we also kind of derived a 30-69. So if I take an equilateral triangle, and they each have, and I give each of them each side a length of 2. And then I draw this bisector here. All of these angles would be 60 degrees. So if I bisect that angle, that makes this a 30-degree angle. And this becomes a 90-degree angle because I'm going perpendicular to this bottom side. And also it comes halfway, so that makes this a length of 1. So if I take just that triangle and I split it kind of out separate, and I say, well, let's take that, what I know here. 60 degrees, 30 degrees. So I know all my angles. This is length 2 and this is length 1. Then what I'm left with is really this. And I can determine that with the Pythagorean theorem. So this is my hypotenuse because it's opposite my 90 degrees. So I'm going to have 2 squared equals 1 squared plus b squared. So that's 4 equals 1 plus b squared. So that's 3 equals b squared. So the square root of 3 is equal to b. So anytime I have a 30, 60, 90 or a pi over 6, pi over 3 triangle like that, I'm going to use that ratio. And it doesn't matter, it could be bigger or smaller, but that ratio for similar triangles is always going to hold. So that's just some of the numbers you can remember. If you have a 30-degree angle, my short side is 1, my hypotenuse is 2, and I just memorize basically my other side is square root of 3.
Okay.
So if I want to know the sine of a 30-degree angle, I say, well, 1 over 2. If I want to know the sine of a 60-degree angle, that's this angle, it'd be opposite square root of 3 over 2.
All right, that makes sense. Thank you very much.
Yep.
I hope that's the same thing I had. Also, on the 21st, I just wanted to make sure what was on my mind.
Yeah.
I'm going to be under sedation.